Welcome back to Azure Everyday with Pragmatic Works. My name is Steve Hughes. I'm a principal consultant with Pragmatic Works, and today we're going to talk for a little bit about Azure DW. Azure Data Warehouse is a parallel data warehousing solution in the cloud that you can use for large data loads and large data workloads in particular. However, as part of that process, it's good to understand some of the underlying architecture and its impact on the workloads you're planning to put into Azure. Today I want to focus around the fact that this is a parallel data warehouse solution. When you implement or when you turn on Azure DW for a workload, it will instantiate 60 SQL Server databases underneath. And what that means is that it's looking at how to parallelize your workload across 60 databases. Unlike the appliance or the APS, you don't really have any control over the number of servers that you run. It's a standard, it's platform as a service. It's designed to handle it without you having to touch it a lot or do anything else to manage that workload. So as you start going down this path, the 60 database parallelism is very important to understand. So I want to look at three different aspects where it affects kind of how you plan, or if you can even see if the workload makes sense in Azure Data Warehouse. The first one is realizing that all the tables by default going into Azure Data Warehouse are cluster column store indexes, and those indexes really are great for compression and performance, but typically need 1 million rows in them before they become compressed. As a result of this, if you think about a distributed workload across those 60 databases, that means that you need 60 million rows before you actually see an effective compression solution based on a standard round-robin distribution across the databases. However, this can be impacted here and there by other types of distribution keys, but for the most part, you're basically going to run this same scenario where you need to look at 60 million rows before you can really take advantage of the compression utilities in that cluster column store. The second thing to be aware of is that when you're partitioning a table, that table is already distributed. And because it's already distributed, that means that you actually have a scenario where a table that, say, has 100 partitions in it. So you start doing the math, well, that creates 6,000 partitions across the Azure DW instance. Furthermore, by breaking it down even further, that means you're going to need about 6 billion rows before you can take advantage of some of the column store index advantages, including the compression. So if you're not really running that large of a system, partitioning may not give you the same benefit it would on a SQL Server or Azure SQL database. So be aware of that change, and partitioning may not be a great strategy for you in Azure DW, and most times you probably want to hold off on partitioning until you have a specific use case that makes sense. The third thing to be aware of is how the data is loaded into the data warehouse. The Azure Data Warehouse, because it's 60 databases, one of the things that makes it a great platform for loading data is the fact that it can parallelize the data load across those 60 databases. If you're looking to get a parallelized load, then you really need to figure out how to take advantage of that. There are a couple tools that really help you with that. CTAS, or Create Table As SQL statements, are designed for use within Azure DW and have the ability to distribute that workload across the partitions and load in parallel, resulting in a very fast load. Using in conjunction with Polybase, you're able to actually pull data from storage like Azure Blob Storage or Azure Data Lake and pull that data through, and then use CTAS to write that data out. And kind of the final wrapper on that scenario is taking advantage of Azure Data Factory and its capabilities to further let you use the parallelism. So if you're using Azure Data Factory to direct load a staging table or something similar inside of the Azure Data Warehouse, you can actually do things like making sure it's sending 60 files at a time, so every server is being used. Those are some of the techniques you can use to help optimize loading, and things to consider when you're wanting to turn on Azure Data Warehouse and see if it will fit the needs of your organization. If you have any other questions, or if we can help you give you more guidance around this, please click the link below. We look forward to talking to you later. Thank you very much.